viewers, welcome back. I'm Eric O, and Ivan is back to join us.
Yep, thrilled to be back, Eric.
Yep, good to have you back, and we've got a brand new car here to work on today, so stick around and see what we find. All right, so what we have is we've got this 2004 Mitsubishi Galant. It's got the 2.4 liter, I believe it is, the 4-cylinder. Automatic. It's got 77,000 miles on it. It was brought to me by the customer, and I guess I'll try to give you the brief history as I was told. So the customer brought it. It's a husband and wife, kind of a younger couple. They bought it. They bought it in a city that's kind of close by, about an hour away. About a year ago, or about a year and 3 months ago. They bought it from a guy. The check engine light was on when they bought it, but it had a good sticker, so they never got it re-inspected, and they never really pursued why the engine light was on. The guy they bought it from told them it was just an oxygen sensor, because that's what
that's what it usually is.
that's what your engine light is always on for, an oxygen sensor, or it needs an oil change. So they bought it. The engine light was on. They drove it. The year's up. The inspection's due. This was 3 months ago, just kind of give you a timeline. So they took it to the shop that they go to. That guy brought it in, and evidently it had a whole host of codes, and he's done quite a bit of work on it. He's evidently he has fixed other codes, from what I'm told. They're left with this O2 heater code, and it's how the customer explained it, and the guy's not able to get this code to reset. So the customer's not real mechanical, but that was his best understanding. So I asked him, well, what's been changed?
Oh, here we go.
So since it's been at the shop, and mind you, it's been at this guy's garage for 3 months now, so it's been there through most of the winter.
So he's changed a lot of parts in those 3 months.
Yeah, so it has new oxygen sensors, and it appears by looking at it that both upstream oxygen sensors. The downstreams, I'm indecisive whether or not they're new. The guy didn't have any paperwork. They may be new. They're different. We'll just leave it at that. He replaced the starter. The starter went bad when it was there. He put an alternator on it, evidently because of an overcharge condition.
No, sure.
Which we're not positive on. He substituted a known good PCM, supposedly. And has done a bunch of testing with the wires. The customer told me that he checked the whole wiring harness.
That looks like it involves opening up the loom and
so looking under the hood, it's been fiddled with. I mean, the wire loom is open, the wiring harness is out. There's clips broken everywhere. There's like some rigged up stuff going on with the battery cable. There's liquid electrical tape on wires that have been poked and prodded. It's obvious that it's been fiddled with.
Got a mild case of molesting.
It's been slightly molested, as we would say. It's no virgin for sure. So with all that being said, that's the only backstory I have. The customer's concerned. He wants the light off. He doesn't know why it's on, and he wants an inspection sticker because the car's been sitting for 3 months at this other shop. He called me the other day trying to pump a little information, wanted to know if I knew something to tell the other guy to look at. I just told him simply that, that we'd have to see it. So I told Ivan about it. I said, hey, this guy called me. He's got this, wild problem. And then, of course, we both got really super interested in it. I was like, well, he didn't say he's going to bring it here. Then all of a sudden, just one day, I look outside and it's here. So that's where we're at. So we've got our Varus plugged in. We just went ahead and just, kind of documented the problem and saved our VIN and stuff here. And we've got down here our list of codes. I'm not sure if you can see those, so I'll zoom in on them for you. So you can see our list of original codes. We got that P0154 or P0154, the P0134, the P0132, and the P0135. So it's looking like no activity on bank 2 sensor 1, bank 1 sensor 1. So both upstreams are not showing any activity according to this. A high voltage or signal high on bank 1 sensor 1. So not only is it appear to not be working, it appears to be high voltage. And then the heater circuit on bank 1 sensor 1 also seems to be kind of a culprit there. The only thing I would say, and that I don't recall, is when I initially scanned this, if it had run a full drive cycle. So that's the only thing I am not aware of. So just kind of keep that in mind, and we'll go from there.
Now let's go look at some oxygen sensor data. And I guess once we pull the data up, we'll start the vehicle, let it warm up,
Yeah.
see if it goes in the closed loop.
Yeah, I don't know about you, but I've seen some pretty good clues. Often just looking at data without key on engine off, sometimes you can get some get some pretty good clues. You know,
right,
that's why I always attempt it before the engine's warm, and at least that's always been kind of my habit if it's possible.
All right, let's do. I'll throw coolant temp up there. Mass airflow, why not?
Yeah, sure.
Bank 1, sensor 1. Bank 2, sensor 1. So it's a 4-cylinder engine, but it's kind of a goofy setup.
Yeah, you got 1 and 4 are on bank 1, and 2 and 3 are on bank 2. It's very, very similar to what Toyota does. It's like, it's kind of, I got a lot of bit of that feedback when I did that Toyota video with the AFR sensors. People are like, two banks on a 4-cylinder. It's like, wow, it is kind of, but see, then your fuel trim though.
Yeah. It's just
fuel
one.
Trim, yeah, long term.
So which sensor is that taking it off of? Is it averaging them?
Yeah, I don't know what the
That's a good question.
What the algorithm is on that. So, but I believe the Toyota had fuel trims per bank.
Well,
but
broke it up.
Yeah, these here just one. So
TPS. I think that's enough right there.
Yeah.
List view.
And then as far as your thoughts on the mass airflow, why you display that is because we have a no activity code. So if we're pegged out lean or something, that would show no activity.
So yeah, just central sensor data is always good to look at if you're starting out from scratch. So let's graph our bank 1 sensor 1, bank 2 sensor 1. Vehicle's off right now. Again, fuel trims are
what you'd expect.
zeros. Yeah.
70 degrees inside the shop here, and it's been sitting inside all day. I guess initial observation for me is nothing really, other than the fact that does this have a bias voltage on? Should this be sitting somewhere else, or But I guess without looking, I mean, they're both downstreams are 0, both upstreams are at 20 millivolts for whatever reason. So I would just say let's start it, because nothing is real. I'm not a Mitsubishi expert, and I don't think you are either. So, so as far as knowing, like, is that supposed to be sitting at 450 millivolts? I don't know, or 2.5. I mean, they're always so different.
How often do you see Mitsubishis?
Yeah, exactly. So
once a year, maybe.
Yeah. We go ahead and fire it up.
Yeah, fire it up. Watching that, right?
Well, it is running and the engine light is on, so.
Kind of sounds not as smooth as it could be, getting loud. I don't know.
Got a rattling heat shield. Sounds like a little laboring. Oh, well, I guess just for the heck of it, just pop out of it and see if that's the only code.
Did it give us open close loop? Loop status?
Boy, there really isn't much data. It did not.
There's not much data.
And that's the only data? Is that just engine?
I think.
Cancel. Oh, look at that.
4,980 millivolts.
That's our high voltage code. I'd say
Holy cow!
That one.
So that's 5 volts basically.
Yeah. Well, yeah, 4.980. Yeah. So.
I didn't know oxygen sensor circuit could read that high.
The fuel trim's trying to make up for that little guy.
Yeah. Oh, what about this guy? It's lean still.
Yeah. Well, it's only been running for just so bank 1 sensor 1 is seeming to have a little bit of an issue. Bank 2 sensor 1, I would think, would be starting to work at this point. We'll let it run for a little bit here.
What did the other guy tell you? It's supposed to be some clean air sensor?
Yeah, the shop he had it at, after several months of being there, said the customer told me that the owner of the shop had contacted his personal contact at Mitsubishi, and because this was an early model 04, that it has special clean air sensors in it, to detect the cleanliness of the air. He gave me this really long story about it, and I was really holding it in. So this evidently is a very special car with special sensors because of its production date.
Well, Mitsubishi does a lot of electronic development, I know. So I think tried something new on.
That's why I didn't bother hooking an exhaust hose to it here in the shop, because I figured it's so clean that we don't have to worry. So,
but still, that doesn't explain our difference there. Even if one's clean air, the other one's not.
Yeah, so I know we've been talking for a little bit, but you can see this O2 sensor is...
I'm going to go over and rub it a little bit.
I'll do that. I'll grab it. Can you just hold it steady?
Yeah, sure. Just snap it a couple times and hold it steady out, like 2 grand.
Ready?
Yep. Yeah, I'm not seeing any change.
Oh, really?
It's flat line 5 and flat line, low.
0.98. Huh. What are the downstreams doing?
I don't know, let's see.
So we got one. So basically we got bank, so here they are. So bank 1 sensor 1 is pegged out at this 5 volt. Bank 2 sensor 1 is just doing nothing.
And the downstreams are...
Bank 1 sensor 2. Yeah. Well, so technically this potentially could be working, because so this is pegged out, fuel trim's minus whatever.
Let's see.
So what's bank 1 fuel trim? Oh, it doesn't have a bank 1 fuel trim.
Well, short term is minus 25, so it's really leaning it out.
Yeah, so if it's leaning it out, this potentially could be working, bank 2 or bank 1 sensor 2, because it's fuel trim's cutting it right out.
Well, let's see.
But why isn't this one pegged right out at 0?
So as high as it got up to maybe 500 millivolts when you snapped it.
Yeah.
That's still not.
Yeah.
It's inconclusive at this point.
Well, I tell you what. So we come over here by the car. Ivan brought the scan tool over. Best thing to do now is it's warm. Essentially, should be warmed up. I mean, we're at 100 and whatever degrees. Where we at?
We're basically
about 160. So yeah, oxygen sensor should be working. They're kind of responding with the throttle snap. We're gonna do a forced activity test, basically.
Rich, lean, just to see if the oxygen sensors are alive before doing any other,
Got the rich condition right here.
So lean condition over there.
Not a lot of vacuum lines on this engine. I'm going to yank the brake booster hose off. That should make it lean. That's just PCB. So I'll yank the brake booster off. We'll give her a little toot of brake clean and see what happens. And I guess one observation we noticed when we came over here is the engine, I don't know if you guys see it in the video, is starting to get a little case of the jitters. So it is quite shaky. It doesn't sound like it's misfiring, just listening to it, but the engine's kind of shaking, but that could all be due to fuel trims being chopped off. We're not going to pay much attention to that now, we're just going to go about our test. So I got you zoomed in. We're still under the hood. What do we got there, Ivan?
We have our downstream sensors at the bottom. Sensor 1, sensor 2.
Oh, no,
I'm sorry. Upstream, sensor 1. Yeah, my bad. And then the downstream sensor 2 is up top. And they're all showing pretty much flatline lean, except for bank 1 sensor 1, which is pegged at 5 volts, which is ridiculous. I've never seen that before. So, yeah, give it a... First do a vacuum leak and see if we see any changes at all.
Alright, so I'm going to pull the brake booster hose right now. There it goes.
Extreme lean condition, right?
Brake booster hose is all the way off.
Engine's shaking like crazy.
Brake booster hose wide open. Try to come off that slow. I'm not seeing anything.
Well, you can see it did change a little bit. Let's try again. So for example, bank 2 sensor 2, downstream.
Yeah, here I'll zoom in on that for you.
There is a change, but it is minuscule. It is a couple, let's see, maybe 50 millivolts right here. See those jump?
Oh, okay, yeah.
The other sensors, no No noticeable change at all.
All right, I'm gonna grab some, got some brake clean.
Yep.
All right, here we go.
Let's richen her up, Eric.
I'll try to do another song.
Yeah, I think it's a fix right there. All right. Well, we have some activity on bank 1, sensor 2.
Still putting it to it.
Yep. He's holding it down. Should be running rich. Almost all out. No other activity really. This is kind of bizarre. It's no other activity. So the only sensor that looks like has
Kind of works.
any activity is bank 1 sensor 2, which is a downstream.
Yeah, but
bank 2
I
sensor
just
2.
put like a half a can of brake clean through
Yeah.
it. It should have
I
pegged
mean,
those.
50 millivolt difference. It changed. Okay, so it's connected to the computer somehow, but yeah, this is pretty bizarre.
That is pretty bizarre because, I mean, even usually, well, you remember that Hyundai test we did with just that little tiny sniff of brake clean, man. It usually pegs them out.
Yeah.
And I was,
Those actually, nothing was wrong with those action sensors,
yeah.
right?
So, and I was,
Nothing wrong there.
I mean, that was almost a quarter can.
I'm surprised you didn't install the engine on it. Just
Well, just last little bit.
Basically
but
did, yeah.
prior to that, I was stuffing it in there pretty good.
Uh-huh.
So he gets a complimentary top-end engine cleaning with the diagnosis. I mean, that's a service. So not everybody cleans the intake for the customer.
What's the next step, Eric? What would you do?
Well, I mean, visual inspection. I mean, we're here.
Yeah, we are here.
I
Yeah.
just shut the key off. We see. It's obvious to me the codes are real. I'm surprised, though. I guess a couple of observations. Bank 1 sensor 1 is pegged. It's at this 5 volts, which is odd.
Yeah,
you know, especially working on a car with 5 volt references.
Yeah. Never seen that before.
Yeah. So bank 1 is pegged. That's true. It's true. Also, it has no activity, which is the other code. Bank 2 sensor 1 was a code for no activity, and that also is true. It has activity, but it's minuscule. It's what, a couple tenths of
Bring
a
the history codes up here.
yeah, a couple tenths of a volt.
Vehicle history. So we had
Yeah, it's big.
no activity in bank 2 sensor 1. No activity bank 1 sensor 1. So both upstreams, which is confirmed.
Yeah, that's confirmed. Yeah,
Right.
and it's high voltage.
High volt. What do you say? Signal high. Bank 1
So-
sensor 1. It's 5 volts.
Yeah, and then
So
as far as the heater,
that's where that's coming
really
from.
doesn't matter at this point. I mean, it's
Yeah. We gotta. Well.
yeah.
I mean.
we could test the heater
Yeah,
circuit, but
That's just for one of them, and then
Yeah.
all 4.
So I don't know. I mean, with bank 1 having a heater code, I mean, maybe I don't know how the heater works. If the heater was shorted out, you know, if it's a duty cycled heater, can that be sending our 5 reference? And if that's true, why wasn't it doing a key on engine off? You know, I don't know
Yeah,
the strategy on these.
So we definitely have some research to do, but for now, let's just take a
Yeah,
quick
let's
look
see.
where the connectors are. So it's maybe something obvious.
I mean, there's.
Let's zoom in and.
All right.
I mean, it's already a mouse nest, I guess. So.
So we'll just kind of come over here to the car and we will observe as we bring you along. So basically, I guess I can give you the rundown on the banks.
What's the layout?
Yep. I believe, I guess I'd have to look. I know it's 1 and 4 on, I shouldn't say I know, usually how it is. So I assume that this is bank 1, okay, because this is where the number 1 cylinder is. It looks like it goes into the number 1 pipe. So this is number 1 upstream. This wire here goes down. So this is number 1 downstream. And then we come over here on this is the passenger side of the engine. So we've got number 2 upstream and number 2 downstream. So it's kind of neat that, I mean, none of these wires are put back. This is how this car came in. It's obvious that these O2 sensors are new. So that's bank 2.
The upstreams are brand new for
Yeah,
sure.
upstreams appear to be brand new. The wiring on them is quite shiny.
And it looks like they do have the factory connectors, so they're not the universal splice-in type. So that's a good sign, I guess.
I don't want to blow the video, but I did do a video on a universal O2 sensor.
Is that coming up soon, Eric?
It's coming up soon,
Nice.
and it worked. It was for a used car dealer. It's an awesome video.
Well, it works long enough to ship it.
To sell the car.
Yeah.
Yeah. Let's see.
Well,
so
at least the connectors are accessible, so.
yeah. Can you okay, so it doesn't plug. Let's see. Can you see around? Can you get that other one? Just kind of curious if it's. I mean, it's plugged in, right? I assume so, 'cause we didn't have-
Nice.
Okay.
So there's our.
And just because I know somebody's probably going to ask, can you invert those connectors? Can that black one be plugged into the gray one? Just out of curiosity. Or has it got locator tabs on? I'm just, you know, because on our last video, remember a lot of people were saying they thought they might be switched.
Right. Yeah, that was a popular guess,
Yeah,
right?
yeah. And that's plausible. I've actually seen that.
Actually, I don't think these can because this one, yeah, see the plugs?
Let's see.
They both have clips, but the gray one
It's
has
got
a little
locator tabs.
things on there.
So they can't be inverted then.
So
Okay,
they're mostly idiot proof.
Well, if you ground the tab off of this one, you could.
Yeah, you can make it work.
So you can make it work. You just need a grinder. So overall, the connectors look good.
Yeah,
At least on that end.
nothing noteworthy on this side.
Let's see. So we'll check these.
Come over on this side.
Look at this. So here's I just noticed something. So here's the harness. This is how it came in. I mean, this harness connector's, you know, been played with. This wiring harness has been yanked out. Looks like it's been probably cut apart. The tape has been cut off it here. I did notice, like I said in the beginning of the video, I seen electrical, this black oozy crap all over the wires, this liquid electrical tape, but I did not notice this. I don't know if you've seen this or not, this wire here. So we've got a wire. This is our bank 1 sensor one, right? Yeah, this is the gray one. So this is our upstream
Looks
O2
like,
sensor.
It's having a bad hair day or something.
So somebody has cut the wire. What wire is that? Can you tell?
It's white with a black tracer, it
Yeah,
looks like.
Where does it go on the O2 sensor? Does it go to
And it goes to a black wire. So there are two blacks,
blacks, so it's-
and a blue and a white
so the two blacks are the heater.
heater. And what about the blue and the white? Which one's the signal? Which one's the ground?
I think the white is usually the ground. The white or the black is usually the ground on it.
Yeah, blue's the signal.
So blue's a signal. So this is top
So
left.
which-
That is a heater. Oh gosh, I gotta watch my camera.
Yeah.
That's the heater.
So the heater wire is cut.
Okay,
Right.
so yeah, and we had a heater code for bank 1
Okay,
sensor 1.
so that's 1 out of 4, possibly.
But why was it cut? 'Cause this
Exactly.
thing's been cut and twisted. Somebody has.
Do you want to twist it
yeah,
back
twist
and
it back
see
together.
if the code disappears? Or
Yeah, unless you cut it because it like caught on fire or something. So I don't know. So I guess we'll leave that.
Yeah.
But you can see there's electrical tape. Look at this purple wire. Is this purple wire cut too? Look at that on the back side. Here, can you dig that out? I'll hold this back.
Yeah.
It looks very, very flimsy.
These wires are the thinnest gauge wires I've ever seen on a car. They're probably try to save some pennies.
Is it cut or is it just the insulation?
Insulation looks a little damaged, but I think it's still whole. I mean, you can pull on it. It's
Oh, okay.
still
All right.
still good.
So they stuffed liquid electrical tape because they probably did some poking. All right, so do you see anything else obvious? These connectors are the same, so I'll assume they can't be inverted. The lower one is unplug the, oops, whoa, hang on. Unplug the black one there if you can, just a visual look.
Yeah, hold the light.
Yep.
Alright, so this guy goes here. There's black. Those look whole
No
still.
pokey marks.
No, this guy is just one broken wire. Visual inspection, and we haven't done any electrical checks yet.
Yeah, so yeah, it looks like one broken wire, some chafed wires. I guess there's some insulation that's been knifed through. Probably,
yeah.
Probably when they cut it out.
So this is what the original one's supposed to look like. It's supposed to be all wrapped up in its own electrical tape, and this one has obviously been unwrapped.
Okay. Well, you can see the visual inspection definitely revealed, quite a bit of tampering, I guess, for lack of a better term on here. You know, we've got the cut wire on the bank 1 sensor one. It runs the heater. It's probably, what's setting that code. But the thing that's peculiar is the other connectors are intact.
Yep.
The oxygen sensors appear to be new, from what we can tell. New doesn't always mean good. Anybody that's in this business knows that new is often
Never
worse.
trust anything, always question everything.
Yep.
Too many variables.
Yeah, new is not good. What we're gonna do next, we're gonna just independently test the O2 sensors. And the reason we're gonna do that simply is because it's easy. This car has the O2 sensors right up front. The connectors are easy to get to, and testing them independent of the car is super simple. So, 2 tests. We're gonna do a heater test, just a simple ohm meter, go across
continuity.
Yep, gonna go across the heater. Probably gonna see 4 to 8 ohms, somewheres in that neighborhood. And then what we're gonna do, that this car uses regular zirconium dioxide O2 sensors that create their own voltage. We're gonna unplug them. We're gonna pull up our voltage scale on our Verus from 0 to 1 volts or 2 volt scale or whatever. We're gonna hook them up, start the car up, and see if they work. There's no sense chasing anything else down. The Verus or the car data says they don't work.
Yeah, we have to verify that the sensors themselves
we're
putting
doing
out a signal. And for the signal test, we're just going to hook up the ground and the signal wire to our voltmeter or whatever. But you just want to think of it as a battery that can produce 1 volt, right? So Rich is going to give you 1 volt.
Lean's going to give you 0.
Zero.
Yeah, so you can do the same thing on a bench test. I'm sure there's a million videos on YouTube how to test an O2 sensor with a butane torch. We're doing the same thing. We're using the car. We're going to get it hot if they respond. You know, if we got a high voltage, I'm going to yank a vacuum leak. It should drop lean, and then we're going to know what we have to work with. And what this will establish is, do our O2 sensors work or not? I mean, is this just? I would tend to think that they work if they've been chasing this problem, but you gotta know what you need to know. I mean,
all 4 of them don't work. That's kind of it can be a coincidence.
Yeah, why start chasing out some silly wiring problem when we got a bunch of crappy parts? So it only takes a few minutes. We're just gonna do the whole thing live, just because we can. How's that? So yeah, I mean, let me go the lane here. So
For each connector.
Yep. We're going to take and I guess we'll just do, we can do our heater test first. So if you give me the leads.
Well, let's try this guy. Does it clip onto it? And so there are male terminals in here. See if I can just clip on a little. See, I think that'll be easier. So you don't have to.
You got another clip?
Yeah, I got another clip.
Okay, so Ivan brought some of these little clips for the Verus.
So I got those from aeswave.com and all the little adapters.
Little female to female adapter. So.
They make nice leads. You can get custom leads and stuff. But anyways, so let's go to our scope multimeter, and first we're going to do the ohm check on the heater circuit. So
and just general reference too, on any O2 sensor. Well, I shouldn't say this. On 99% that I've seen, the wires that are the same color are the heater, whether it be 2 grays, 2 whites, 2 blacks, and they're typically side by side. Well, on a 4-wire connector, they're always side by side, aren't they?
Well, they could be
diagonal.
Yeah. Usually they're side by side.
Yeah.
So let's go to 400 ohms. That's the lowest scale.
Okay.
All right.
Let's see. So it's open.
Yep.
It's closed. So we're good. So right now, I'll just kind of back out of this real quick and show you what we're doing. We've got our connector here. On this particular one, this is bank 2 sensor 1. Our 2 black wires. Just gonna probe on in. I expect to see like say 4 to 8 ohms or something. And then we can see here, where are we at?
5.5.
Yeah,
5.5.
Yep, so just on an average, I would say that heater is good. Getting it right here.
Yep, doing well.
Got that one unplugged. This one is also 2 black wires. Check this one. I got a good connection. So this one is a little high resistance. This
Well,
one
that's
is,
interesting.
Yeah.
Let's write these down since we're real scientists and we'll actually take notes and.
Bank 2 sensor 1 was what, 5.6?
5.6.
Bank 2 sensor 2 is 12.7.
Yep.
And you got to label your label it, right? Yeah.
Ohms. You know, a little ohm symbol.
Yeah, it's the little delta.
Yeah.
I didn't mind one draw because it would just look like a circle. So, all right. So I'm gonna unplug these. So we're going over bank 1 sensor 1. This wiring harness is such a mess. Yeah, I hate it when shops do that.
Alright, these 2 guys.
Yep. So right now Ivan's plugging into bank 1 sensor 1. And
The one with the 5 volt signal.
Yep. And that one is at 5.6.
5.6, so yeah, consistent with first one.
You can go ahead and plug this. This is the downstream. Bank 1 sensor 1. Oops.
See, this one has different wire colors. It's actually 2 whites for the heater.
Oh, okay.
It must be a Bosch or something.
Yeah, because this downstream was 2 blacks.
Yep.
Awesome.
And we got 13.0.
I wonder if the downstreams are...
Maybe they're different spec?
Yeah, they must be different spec. I wonder how the heater works on this, if it's a duty cycle or if it's a constant.
Yeah. Maybe the higher ohms one is a constant and
yeah, because that was 12.9. So yeah, so both the downstreams were almost 13 and the upstreams were almost 6.
Okay, so that's not too strange.
Yeah, it's not too strange. I've seen on air fuel ratio sensors where they run a higher duty cycle, it makes the heaters run hotter, and they have a higher resistance.
They have a higher resistance.
Yeah, if I remember right.
If you have a lower resistance, you can send through more current.
Yeah, and you would think. Huh, so anyhow, I guess.
So at least our heaters are intact at this
So
point.
the heaters are intact. Next test, I guess just switch your leads there, set it up on a voltage. I'm gonna fire the car up to get it, to get these things heating up, because we're not gonna jump wires to heat them.
So let's go to,
So as he's setting that up on the 1 volt scale, we're just gonna use our leads again. We're gonna go across the 2 wires on the O2 sensor that are opposite colored. You know, in this case, a white one and a blue one. This one is a white one and a blue one. I think the blue one's a signal wire. If I'm wrong, the graph will just be inverted, so it's no big deal.
so take your lead, make sure you have
Yeah, sometimes you can pick up noise on your scope from a fluorescent light, or if it's plugged in, or you know, some noise from the alternator. There you go, there you go. So that's an upstream. Let me, so you took to the upstream. Let's zoom in on the graph here so they can see that.
So average right now is about 0.3 volts.
So where are you at now?
0.3.
Okay, what was on the display? It was a bank 2 sensor 1. Well, we were stuck at like 0.098 or something, right? Wasn't it like under 100 millivolts?
It was under 100 millivolts, yeah, right around 100.
Okay, let me, I'm gonna whap the throttle.
Yeah.
Keep an eye on this.
There's no throttle by here.
Electronic.
Oh.
My wire. The cable is way too complicated. You ready?
Yeah, that's right. Yeah, go up.
Going up.
Go up. And obviously, there's no feedback right now, so don't expect an oscillating pattern here. We were just checking for the range.
Yeah, but we can make one.
So it,
Brake booster knows kind of, I wonder if we can just get some faults there.
yeah, sure. So at this point, it looks like the range is there. It's hanging out at 0.8.
Okay, so what I'm gonna do, the brake booster is hard to, it's kind of a pain to control. I'm gonna take the tube right here off the mass airflow sensor and let in some false air. It should force it lean, technically, I think. So I'll zoom in on that, and I'll just let you guys know. Okay, so I'm gonna create false air with the mass airflow. Right now, the hose is coming off. Now I put it back on. Now it's off.
Nice.
Now it's on. So that tells me that the information the computer is displaying to us on the Veris is a lie, at least on that sensor, because it's obvious that this sensor works.
The sensor, yeah, it looks functional.
Yep. See if the downstream's heated up enough.
Alright, switch over.
So when Ivan plugged into the downstream initially, I suspect we didn't have a reading because the car hasn't been running long enough. Plus we have no heater going to it, so it's going to take a while for this downstream to heat up. It looks like it's starting to work. Let me zoom in here. I'll go rev up the car for you.
You have some brake clean, maybe force it rich.
Oh yeah, we could give her a little toot of brake
right
clean.
in the,
I'm going to spray some brake clean in ahead of the mass airflow.
yeah, make sure you spray it downstream. You don't want to harm the after. Now rev it up a little bit.
Try holding it steady at like 2,000, 3,000. Yeah, it's coming up, Ivan. actually just forcing it hot. All right, go ahead and let it idle.
Okay, now do a vacuum to keep it dropped.
All right, so now I let it steady out here. So we're at about 500 millivolts, kind of starting to steady out. So I'm going to pull the tube off and force it lean. It might take a little while to respond, but the hose is off right now.
There it goes.
Oh, that was pretty quick. Now the hose is back on. Hose is off. It's a little slower to respond, but it does treat the catalyst. So hose is back on now.
Basically, the heater's there for a reason. These wouldn't warm up at all if there wasn't, you know.
Right, well, I'm not sitting here idling. I mean, it took you a while.
Yeah, it took me a while at 3,000 RPM.
We'll see, we're holding around 500.
So this is way more than we saw in the scan tool.
Yeah, because that one was stuck too, right? Well, no, yeah, well, none of them got above 250 millivolts, even, you know, it kept spiking it.
Let's see.
There you go. So, okay.
Oh, wow, yeah.
Let me zoom in on this. So this is what the oxygen sensor is really doing. I got a little glare there, Ivan, so just go ahead and explain it. Well, just explain in case it's not showing up good.
Okay.
So yeah, what do you have for voltage?
So we're live at 0.93 peg rich.
So you're.
And you go back home, scanner.
What's that saying?
39 millivolts.
Really?
And this is the Bank 2 sensor too, right?
Yeah, and that's where you're plugged in.
Yeah. So our computer is not, either it's not getting the signal or it's not reporting it, you know, correctly on scan data.
Okay.
But our oxygen sensor itself seems to be working just fine.
If you go back, yeah.
And, you know, create a vacuum leak up there. There it goes.
Yeah, so you had a glitch in the wave. So, oh, yeah, big time. So, now this is only 2 out of 4 oxygen sensors. We could probably assume the other ones are doing the same thing. It takes a second to test it.
Yeah.
We're just going to run them down and see. But right now, this is, I think this is a little bit of a game changer. We got 2 known goods.
Yeah.
We know what it is reading plugged in, so we don't have like a short wire bringing the signal down. But it doesn't mean it's getting to the PCM.
Well, which wire? Just from the sensor to the connector?
Right, yeah. I mean, it's not like those 2 wires are shorted and kill the sensor.
Okay, yeah. So when you plug it in, the signal stays.
The signal stays at the sensor,
okay,
but for some reason, the black box is not. So yeah, let's just finish checking our other 2. This is pretty cool actually. You know, despite things here. So here. Got your little clips.
Yeah, I'm just back from then we can do it plugged in.
Sure. So we're going bank 1, sensor 1 now. This is the one that was shorted out high voltage. Remember, keep that in mind. So I don't know what we're expecting to see here. It looks like that wire is backwards, I think. You plug that in, it was minus. Oh, okay, you actually had to switch. Okay. Yeah. I thought maybe we were on something.
Yeah, sometimes. You gotta check your polarity.
Yep. Rookie mistake.
Oh man.
Rookie mistake.
No, I'm gonna have to own up to that one. White, blue.
That's the sucky part about doing it live.
Why can't they just make them red and black?
So that's bank 1, sensor 1.
So that's actually pegged out rich right now. We can do a little vacuum leak action.
Okay, so that's showing us the same results as the other 2 O2 sensors. Being that you have that back probed, you said you're going to plug that in.
Yeah, see if the signal stays.
So
this guy.
Well, this one was a broken heater wire.
Well, yeah, let's see if the signal stays there.
Okay, so that's plugged in, bare wires. No, it's pegging out your scale.
What happened there? Let me get a good connection reference.
Okay, I'll hold this. It looked like it pegged out your scale.
Okay, right there, right? Point 6.
I'll hold that.
Yep.
So you got a good connection.
Yep.
Plug it in, and look, so it pegged out your scale. Change your scaling.
You went down. You went down. Look.
Here, let me show the viewers what you're doing. so what happened here? We plugged this in. So we had a good O2 sensor. We plugged it into the harness.
What? Minus 5 volts?
Oh, it went negative? So you changed it to your
Negative? Yeah. Wait, unplug it.
Okay. I'm gonna unplug the O2 sensor's unplugged.
So our live reading right now
Clicking again.
is... Okay, so it's going up. This is live, 0.5, 0.6.
Okay.
Well, let me change the scale just a little bit. Let me go 10 volt.
Let me see. Yeah. Let me turn the camera here.
So this
It's pretty
is reading
good.
wonderful here. Okay.
So where you
So live, we are at 0.7. So you know, on the rich side.
Okay, I'm gonna plug it in.
Plug it in.
We're plugged in.
Wow. Negative 6.7.
Unplugged.
Back at the normal range.
Okay, so we got something funk going
Wow.
on here. But we have a good oxygen sensor.
Yeah, the oxygen sensor itself is fine.
Did you make a lean condition on this one already?
I think so. Obviously the
Oh,
scale
okay,
is
you're
up.
on wrong scale. Okay,
Yeah.
okay.
So when we plug it in, our signal goes to minus 6.5 volts.
but
Let's
unplugged.
write that down.
Okay. Okay. So, all right. While we're right here, let's just do our last test.
Yep.
That's a funky one. So we're gonna do bank 2, sensor 2 now, or bank 1, sensor 2. You guys are gonna be so confused by the time we're done.
Yeah.
Bank 1, bank 2. Working on a 4-cylinder. Okay.
All right, so back to our regular scale. 1 volt. So we're at 0.3.
Oh, this is downstream. I'm like, why is that reading so low? Okay, so that's downstream.
So empty vacuum leak. There we go.
Okay, so that one responded.
You want to rub it up and see if it goes a little richer?
Yeah, might as well. So right now we are at 0.303. That's good, Ivan. Yeah, it's climbing. So yeah, obviously the converter's heating up there. So go ahead and drop it lean again just to verify, I guess. Yeah, them downstreams take a little while to respond to a lean.
Sure.
So there it goes, yeah, so. All right, being that you're right there, I'm gonna keep zoomed in. I'm plugging it in.
Yep.
I'll tell you when it's plugged in. Let me make sure we got a good connection.
Yeah.
Okay, we've got a good connection. I'm gonna plug it in. It's plugged in right now. We picked up some noise, big time. And what's it doing?
Going up to the point, rich.
Oh, well, the heater turned on, right? Plugging it in, plugging it in, and turn the heater on.
Sure, let me drop the scale a little bit.
Is that? Oh shoot! Let me see if we're still zoomed in. Sorry, guys. Get a little excited. Okay,
So we're almost at 1 volt.
we're at 1 volt. I'm gonna unplug it. It's unplugged, and that's kind of what I would expect because the heater's still hot, right?
Yeah, yep.
So it should drop slowly, maybe.
And then vacuum leak.
Yeah, okay, yeah, there we go. Now if I plug it in, oops, got a little loose connection here.
Yeah, that's a variable, huh?
Yeah, that's a variable. There you go.
All right, plug it in.
Okay, plug it in. Yeah, it gets a little noise, I think, as the heat. Now, yeah, we're losing a little connection, but I think that noise initially. Here, we'll just plug it. I'll zoom there. I mean, I think we did enough to verify that it works.
So, yeah.
I think that noise when we plugged it in is from the heater. You know, the heater initially turning on. Because you see how it oscillated a little.
Yeah, that's true.
That would tell me that maybe that heater works on a duty cycle.
Well, we're measuring the signal, so
Yeah, you wouldn't
I don't know
think
if there's interference there or not.
Yeah.
But in any case, the signal stayed there. The amplitude didn't change.
Yeah.
So our oxygen sensors are all functional.
Yeah, oxygen sensors work. The heaters.
Heaters have continuity.
Yep.
And they're consistent, bank 1, bank 2.
Let me shut this off. Holy so much clean air.
Yeah, those clean air sensors, man.
I'm getting really tired. We have a hose on it, so before you flip out. So if one of the children over there pass out, though,
Yeah, right.
we opened the door. So,
Air it out a little bit.
all right
now.
Well, I think we've.
I think the black box is suspect here.
Yeah. So I guess summarize. We got 402 sensors at work. Heaters seem to be working. The scan tool, however, is not displaying what we are seeing, on the exception of. Well, you know what's weird is this one's reading -6 volts, but it's displaying 4.99.
Yeah. Completely weird.
I don't know if that has the ability to display. I've never seen an O2 sensor display negative.
I've seen like 1.2 maybe.
Yeah, well, I've never seen one display negative voltage though. You know, on this we're measuring minus.
Yeah.
So
there's something.
I tell you,
from the signal wires, there's something backfeeding causing the. What we're seeing, -6 volts. No oxygen sensor is going to actually produce that signal.
Yeah.
So it's coming from the computer side, from where the harness side.
So we've got some wire diagrams. And, I mean, now that we have a control, we know our O2 sensors are good. And and so the problem is from there out.
Yeah, wiring diagrams.
Somewhere.
Sure, let's see where they plug in and the pin out of the computer.
Yep. And then we're going to have to do some tests to see where these signals are going. We know exactly. We got to hear, are they making it all the way to the mysterious black box? And then the thing is, the car runs good. I mean, it seems to run good. I mean, it revs out. Yeah. It's got a little shake, but so yeah, it's interesting. Let's see what we got.
Yep.
So we were just getting ready to go look at a wiring diagram. I haven't had a great suggestion, and I'll just let him explain it.
So when we're looking at OEM data, first of all, we didn't see a PID that I was looking for, which is closed loop or open loop, right? Because in this case, that'd be pretty key if you're trying to compensate for anything. So basically, let's go into OBD direct mode, and that'll give us a standardized set of data. That should give us closed loop, open loop for sure, and see if bank 1 is actually different from bank 2, because we have 2 sets of oxygen sensors. So we should have 2 sets of trims, unlike OEM data, which only had what?
Well, I had one.
You only had one.
Yeah, it had 4 oxygen sensors. 2
short-term and long-term. That was it.
So
that was kind of peculiar.
Yeah.
So let's just go in here and see what data actually displays.
And I assume if there is a closed loop display in there that it is going closed loop, just because our fuel trims did start to change, and typically you don't see that until that transition, So that's just an assumption, though. So it would be kind of neat, though.
Or maybe it's closed loop trying to get somewhere. If it's fall, they're different.
Yeah. There's
variables there.
all these cars are so stinking different.
So let's see
I'll
our list.
zoom in on you here. So it's right now it's key on engine off, just to kind of. Sometimes this takes a little while to detect which protocol it uses and how many, computers are on board and does its whole. Okay, there you go. That went pretty quick.
There's a list.
I'll try to get this set up for you here. Okay, there you go. That's pretty good.
So actually, this list looks more thorough than the OEM one, which is kind of strange. So let's go to see how many PIDs we have.
This is
actually there's more information here. It looks like than the Mitsubishi OEM room, but okay. So we do have our fuel system.
Oh, okay. So we are going to be able to see how many is there. Oh,
fuel system 2, fuel system 1. So it is looking like we do have separate control on each bank. Okay.
That's interesting.
Short term bank 1, bank 2, long term bank 1, bank 2.
And on the OEM data, it was only showing us short term, long term.
Yeah.
Well, what will be interesting is when we look at this, if bank 1 or short term bank 1 and bank 2, if they're going to exactly the same number. You know what I'm saying?
Yeah.
If it's just
exactly.
So I'd be curious to see if these are actually independent.
What else do we have? Our voltages, and then short term fuel trim based on bank 1 sensor 1 and bank 1 sensor 2 and the downstreams. So that's
short term.
Another variable. Yeah, your short term can actually be based on your downstream. So you can have a whole different backup strategy.
That's funny. In our last video with the Hyundai, a viewer mentioned that and I don't know if this is true or not, but he had heard or he's read or experienced that sometimes downstream O2 sensors will play a role in fuel strategy.
Yep.
And being that it has a short-term trim on it downstream, I wonder what what the computer takes.
Yeah,
into account.
exactly.
So that's kind of neat.
Actually, James Danner, Paul Danner's brother, he posted a video on a Toyota Highlander.
I think that guy mentioned that.
Yeah, a downstream sensor that totally threw everything off.
Yep. Yeah. No kidding. That's it. We'll see if we can find a link to that.
Yeah. So let's just look at fuel system 1 and 2, short term, bank 1, bank 2, and our long terms. And I guess all the voltages, right?
Oh yeah. Yeah. Display the same out. You want me to start the car? Oops.
So let's see our baseline. What is it? Key on, engine off. Short terms are at 0, long terms at 0, open loop.
Fall.
So fall in system 1, open loop, driving, system 2. Well, let's start up and
See what does that.
notice our bank 1 sensor 1 is in, for some reason, almost looks like it has a bias voltage or something. What's that?
Well, just as a note too, everything is plugged back in. I guess we should mention everything's plugged in. Bank 1 sensor 1 is the one that was pegged out at 4.98 volts. It's the one that when we plugged it in was reading minus 6 volts.
Okay.
And now here in generic OBD2 data, it's reading 500 millivolts. And
Variables upon variables.
finding,
Bank 1
oh look,
sensor 1.
here's closed loop, fuel system 1.
Fuel system 1 was a closed loop, fuel system 2 is an open loop. Now let's do voltages for the other sensors.
So that the downstreams are reading what they were in the regular data.
Yeah, they look like they're all leaning.
Oh, fuel system 2 is closed loop now. We got two closed loop statuses.
Okay, so it's trying, let's see what the,
And the other downstream is stuck at 0.20, which it was in the factory data, but that bank 1 sensor 1, look at that.
going up slowly.
Yeah, but that's odd that it's,
You want to see what it's actually doing?
I'll probe it. I'll zoom this camera out so you can see what we're doing. So
Bank 1 sensor 1.
So that's the great connector here with the broken wire. And we've left the wire broke intentionally, I guess, for the purpose of testing. We're gonna just probe it and see how it compares to this generic data. This is kind of bizarre.
Actually, no, it's
1.275.
Okay. Look at our short terms. For bank 1, because the sensor is apparently pegged high, it's going, taking fuel away. And then for bank 2, since it's pegged lean, or low voltage, it's adding fuel. And both of the banks are closed loop, so it's trying to compensate, it's trying to get the oxygen sensors to react, and it's not getting anywhere. So I'm curious what the actual voltage is on bank 1.
I've got it back probe right now for you. I've pegged out your scale. So it's probably still that's
Wait.
right here. Change it back here, 10 volt scale. Yeah, mine. Now we got a different reading.
Wait. How? We're still connected, right? Right. Blue is the signal.
Yeah, you want me to unplug it?
Yeah, sure.
Unplug. Yeah, let me make sure I've got this in correctly. Bear with us, people. Trying to do this live.
Negative 0.3.
Let me zoom this out here so people can see what the heck's going on. So we're trying to back probe our bank 1 sensor 1 again.
Okay, there you go. 0.2, right? That's normal range.
Okay, it's starting to heat up.
Yeah.
Maybe we just take it back and leave it. Yeah, okay, so it's responsive. Okay, so yeah, so our upstream O2 sensor is what, about 0.3 volts. So,
and the reading in the scanner.
zoom back in on that.
Yeah.
We're still unplugged.
Yeah.
So let me plug this in.
Look, bank 1, sensor 1, it's lean now. The computer's saying lean.
Well, it's unplugged.
Yeah, but we assumed that the voltage is coming from the computer side. Sensor wasn't even doing anything.
Right, yeah, because when we plug it in, that's when we get it back.
Plug it in, watch this number right here.
Okay, so let's see, we're gonna plug.
Fuel system 2 is an open loop now.
I plugged it in, now it's shot rate to 1.275.
Alright, what happened on the multimeter? Minus 0.9, or minus 9.9. Minus 10 volts now? Before it was like minus 6 or something, right? Minus 5?
Yeah. And then on the factory data it was 4.9.
That is the most bizarre thing I've ever seen.
So, okay. Well, I guess what we can take away from this is our generic data gave us, we got some loop statuses. So that's,
yeah,
you know,
okay.
I guess before we dig out wiring diagrams, that's cool. We've got loop status. Every sensor is reading exactly the same as it was on the factory data, minus this bank 1 sensor 1, but I don't know how it interprets differently from OE to generic.
Yeah.
And then both of them are lying basically from what we're seeing at the sensor, but it doesn't mean that's not what it's seeing at the PCM. So I think we're back to getting our wiring diagrams. And
so what are we seeing here? Fuel system 2, that gave up, right? That's open loop.
That went open loop.
Short terms, not changing
And
anymore.
they're plugged in. Everything's plugged in.
Yeah, fuel system 1 hasn't given up yet. So it's trying to compensate for this peg-rich upstream, take fuel away.
Shut fuel away. So it must be seeing a high voltage, but why are we getting a negative reading here? That's seeing a high voltage.
I think it's time for some wiring diagrams and
Shut it off.
computer diagnostics.